Good morning. Welcome to this training program on artificial intelligence in agriculture. I am Dr. Sudeep Marwa, Head and Principal Scientist, Division of Computer Application, ICR ISRI. You can reach out to me on this email, sudeep@icr.gov.in. Let's start with the first topic, artificial intelligence in agriculture introduction. India has emerged as fifth largest economy of the world. Agriculture and allied sectors contribute significantly to Indian economy, about 17 to 18%, and it is much higher than the world's average. Explosion in digitized data and technological advances in information communication technology play a pivotal role in achieving the digital agriculture with the use of modern digital devices and AI to develop solutions for intelligent agriculture. AI is a branch of science that attempts to develop tangible or intangible systems which not only behave intelligently but also display behavior to the same level as human beings think and act. The word artificial intelligence is not new. It was coined by Professor John McCarthy of Carnegie Mellon University, Petersburg, way back in 1956, when he developed a Lisp programming language for artificial neural network simulation. AI strives to achieve human like performance in all cognitive tasks using purely logical reasoning. In short, AI is intelligence demonstrated by a machine. As we all know, artificial intelligence is the capability of machine to imitate intelligent human behavior, and it is accomplished by studying how human brain thinks, act, and how human brain learn, decide, and work while trying to solve a problem. Let's focus on few points which are for different fields of application of AI techniques. But before that, let's try to understand more about intelligence. So intelligence is basically, we can say, can be divided into these five main attributes. A person is called intelligent when he is able to reason well. A person who is able to reason about a particular problem or a solution or any other thing is said to be more intelligent than the one who cannot reason about it. So reasoning is a very important attribute of an intelligence. The next attribute is learning. As you are aware that as we grow up, we come across a lot of experiences in our daily life, and we learn from each of those experiences. And as we go older and older, or we can say we go on maturing, we tend to learn more and more because our experience increases. And based on that experience, we tend to take all the decisions in our life. Similarly, with the machines, if the machine can learn by providing the machine more and more data along with the computational logic, we can say that machines can learn. So learning is another very important attribute of intelligence. So if a system can learn, then we can say that it is intelligent. The third attribute is perception. Perception is, you can say, about a perception about a particular person or an object or a particular concept or a situation. So if you can perceive, that means before it happens or if any action happens, if you can predict how it will behave, then the machine or that person will be called as more intelligent. Because if the perception is true, then the concept will go as per the perception. So if a person is able to perceive, then we can say that it is able to predict in a way, and that's why he or she or the machine is more intelligent. Then we have a problem solving. So how to, given a particular situation, how to solve a problem. There can be many approaches, but if a person is able to solve a problem in a quick and intelligent way, or you can say quick and efficient way, we can say the person is more intelligent. There can be many situations and many ways to deal a particular problem. One way is to divide into smaller problems, tackle each small problem, and then combine together. The others, there can be other options as well. So, if a particular person or a machine can solve a problem and an aptitude to solve a problem, we can say it is intelligent. Then comes the linguistic intelligence, which is very important because as human beings, we communicate through linguistic, either through reading, writing, or speaking. So, linguistic intelligence is very important. So, if a person is able to express his ideas in a nice way, we can say that he is more intelligent than one who is not able to. And similarly, machines, if they have a linguistic intelligence, they can do many other tasks. And now focus upon here from which subjects we can say artificial intelligence is derived from. As you are aware that artificial intelligence is an integral part of computer science, but computer science has its groundings in mathematics. So basically, computer science is evolved through maths. So these two subjects are basics for any artificial intelligence program or algorithm. But there are these three subjects: philosophy, psychology, and sociology. It deals with how human beings behave in a particular manner, and there are many theories which are built up in these subjects. And since we are trying to imitate machines to do the same behavior as human beings, so the theories in these subjects, sociology for social, as a human being is a social person, so how one computer can interact with another, and if a computer or a digital assistant is a digital self of a human being, then how it will react with other persons, as well as the philosophy and psychology of a particular person, how he or she behaves in a particular situation, and if the same thing happens to the machine, then how machines will behave or how robots will behave. So all these things we can say that we can rely on the theories of all these three subjects: philosophy, sociology, and psychology. And obviously, you can say that when you have listened the word artificial neural networks, which is essentially based on neurons, uh, which are actually the building block of our brain. So, how a signal is transmitted from one neuron to another neuron, and finally it is converted into a particular concept in our brain, is how the totally is through neuron science. And basically on that we have developed artificial neural networks, and then which is again the basics of deep learning. And obviously the biology as a human being and as well as the other habitat on the earth, we tend to learn many things from many biological phenomena, and we try to model all those phenomena into a computational model which becomes the basis of artificial intelligence. So all these subjects you can say are basics building block of artificial intelligence. So artificial intelligence itself is a multidisciplinary subject. When we come to this side, you can see there are different tasks which an AI can perform. And we generally divide AI into multiple tasks like expert task, formal task, and mundane tasks. Expert tasks, let's see what are those. Something like financial analysis. Financial analysis, you can see there are stock exchange, there are a lot of data coming, streaming data is there about low and high of a particular stock price, and huge amount of money is involved. And if somebody can predict the price of a particular share, Then a lot of mathematics goes into it, and complete trend analysis is required. So financial analysis is one of the main tasks of expert task, and where a lot of AI is used. Second is engineering tasks. There are so many examples of engineering where we can apply AI. It includes robotic arms in factories, and it also includes many other type of data analysis which we can use in engineering tasks. Then there are scientific analysis. As we scientists, we collect a lot of data, and all that data has to be analyzed. And there are ways and means in AI to do that in a more efficient way than a regular way which we do as a normal analysis. Then medical diagnosis itself is a huge domain, and all the machines which you see, maybe ultrasound, maybe CT scan, maybe MRI, all those have a lot of algorithms, AI algorithms, which can, by through which they can do image analysis, which they capture. And image analysis not only in RGB, but in infrared, ultraviolet, and all other radiations. And based on that, the machines predict many things. Then comes the mundane tasks. These are regular tasks, basic tasks of AI, which I told, like perception, common sense, reasoning, and natural language processing. So these are basic tasks of AI, and a lot of advancements has gone in, and which has resulted into complete revolution in our daily life. One such example can be your digital assistants like Siri, or you can have Alexa and all that, which you can ask any question and they can respond back. We have now Chat GPT, which you can ask any question and it can write down. It can also generate different type of images. We call it generative AI. There are reasoning engines wherein we have expert system and all, where one can have one fact, then another fact, and then certain conditions, and based on that, one can reason about and can deduce another fact. We have common sense. As from where common sense comes? Common sense comes from our day-to-day experience, whatever we see, whatever we observe, and based on that, we can say that something happens, and we can say it's common sense for a particular person. But if machine has to have that common sense, then it needs to have a lot of data about each and everything, and which is very difficult, and it looks very simple, but to machines to have a common sense is too difficult. And but there are a lot of works which is going on, and huge models have been developed which can help machines to have common sense. Then there are formal tasks like mathematical equation solving or games like chess, etc. And you know that machines can even beat grandmasters. So these are basically, we can say, that AI tasks which AI can perform, and there are many more and many more combination and permutations among each of these, where we can say that AI can help us. If we divide major sub areas of AI, I have listed just 10, but there can be many more. And these areas are not distinct, totally distinct with each other. Rather, they are only, you can say that these are overlapping with each other to develop many, many applications. To first start with natural language processing. As we are aware that natural language processing focuses on interaction between computers and human languages, enabling machines to understand, interpret, and generate human language. One of the main tasks is translation. As we know that in India, we have 22 languages, official languages, and many more languages. And our farmers speak all those languages. And most of our knowledge, which we as a scientist develop, is in English. And then we need to convert that into local languages, Hindi and other languages. And if we can very seamlessly translate from one language to another language, it can be of great help to the farmers because one text can go in multiple languages in a seamless fashion to all the things. So knowledge dissemination becomes very easy. We are close to that. We can achieve 80 to 90% as of now, but still we need human intervention. So that we need to have confidence that whatever we are saying, it's converted faithfully. The meaning is conveyed the same which we want to. But as of now, it is not happening 100%. But yes, the time lag is reduced. So if you want to convert one document from English to Hindi and Hindi to any other language, you just need to translate. There are many tools like Google Translation and other, which there is a tool called Bhashni also available, wherein domain specific things are now available, but 100% is not available as of now. So we at least need to see once, we need to change certain paragraphs, we need to proofread once before we send it to the farmers. But if it happens automatically with 100% confidence, that will be great. So that is one of the main future areas of AI where the translations can happen seamlessly, and if it is delivered with 100% confidence, then we can say that a lot of hardship can be reduced for the Indian farmers. It also includes other things like transliteration. It also includes like text to speech, speech to text. So for an illiterate farmer, if you give a particular text and the computer speaks out, and which is now possible and very much happening in most of the application, it is also very useful for illiterate farmers because by clicking on a sound button, the mobile app or the computer can speak out whatever is happening. So natural language processing is one of the main areas of AI. Second is the computer vision and image analysis. Computer vision basically enables machines to interpret and make decisions based on the visual data. Many application includes it also includes facial recognition, such as Digi Yatra you have seen that you can very seamlessly go to the airport, which happens with the your face recognition. This is a application of a computer vision. But in agriculture, there are many other problem solving ways we can use computer vision, and one of that is disease and pest identification or identification of physiological disorders. By just uploading an image of a plant, you can identify disease. And then once the disease is identified, you can very easily tell farmers what a particular solution to that particular disease is. And combined with natural language processing, you can send him the text and which can be read out for the illiterate farmers. Similarly, there are image analysis techniques available and which can be used in GIS, which can be used in high throughput phenotyping, in crop improvement programs, maybe in protein analysis, maybe other studies in bioinformatics as well. So huge amount of data is available in one form or the another, where we can use computer vision algorithms and image analysis algorithms and can reduce many things. Obviously, for having these two are divided like natural language processing and computer vision. These two are very important areas. But the next two, which I'm saying, machine learning, ANN, and deep learning, are the techniques which can be applied to these two areas. And with machine learning, there are many techniques which we'll be discussing in this training program, like SVM, random forest, artificial neural networks, and deep learning. All these are part of the machine learning. And I have specifically categorized ANN and deep learning as a different topic because today's AI revolution is because of ANN and deep learning. And many applications have come up. The pest and disease identification is one such application in the area of computer vision and image analysis, which is solved through deep learning. So there are many deep learning algorithms. There are many platforms available, and all those will be discussing in this training program. Then comes the knowledge representation and expert systems. Knowledge representation is one of the key area of artificial intelligence. Whatever knowledge we have, we need to represent in such a format which computers can understand and the algorithms can work upon it. One such knowledge representation technique is ontologies, wherein the and ontology is basically an XML based technique, and ontology web ontology language OWL is available, which can represent many type of information in a way where computers can understand, and expert systems can be developed over those that knowledge representation. Expert system, if you say, we can define that an system which can act as an expert is called an expert system. And as you are aware that experts are scarce, a good expertise is always very valuable. So if a system can behave like multiple experts and it can gather information about from multiple experts and can become a super expert, that will be really useful because the system can be active 24 by 7. It can be replicated 10, 100,000 times, and the system can actually solve the problems of millions if it is available at each and every point of time. So it's very important that a good expert system in agriculture exists and which can solve many problems and can help farmers. Then comes the fuzzy logic. This is in comparison to binary logic. You can say we say fuzzy logic because the fuzzy logic helps us in uh, areas where we can say there are many valued logics. So is a form of many valued logic that deals with reasoning that is approximate rather than fixed and exact. So its applications exist in control system, decision making systems, pattern recognition, etc. It handles uncertainty and imprecision in a better way than the binary system. Then comes the evolutionary computing. As I told that we learn from many biological phenomena. So evolutionary computation has many important algorithms. We call it genetic algorithms as well. So here the concepts of evolutionary computings like mutation and uh, randomness, etc., are modeled, and many algorithms which are inspired from biological computing, biological phenomena are covered in evolutionary computation. Swarm intelligence is one such biological phenomena wherein the swarm means the group, like a flock of birds, or uh, you can see the ants, how they behave, and based on their intelligence, how computer can have multiple type of algorithms which can be used to solve particular problems. And basically, it deals in area of optimization. So swarm intelligence involves the collective behavior of decentralized, self-organized systems, typically made of population of simple agents. Uh, as I told, the optimization problems can be solved. It helps in taking decision in robotics, network routing, etc. And examples are ant colony optimization, particle swarm optimization, etc. And the advantages of swarm intelligence is these algorithms are highly scalable, robust, and flexible. Then cognitive computing comes. Cognitive, you can say that cognitive computing refers to systems that mimic human thought processes in a computerized model. And these can be very useful in healthcare systems, financial analysis, customer service, etc. And key features include contextual understanding, adaptive learning, interactive capabilities, etc. And many such systems like IBM Watson is one such example, which can be used for many purposes. And one of the main purposes is medical diagnostics. Then comes the robotics, as you are all aware. that robots are now available even in the agriculture field. We have robots where which can identify weed and can remove weeds from the fields, and there are many other things which are available. And we have one such topic also included in terms of robotics in this training program. So coming forward, what are the capabilities of AI? So AI together with Internet of Things and sensor technology can be of great enabler of precision agriculture. AI can also play a critical role along with the remote sensing technology in wide-scale implementation of climate-smart agriculture. Precision farming is one of the most discussed areas in the farming today, and drone-based images can help in in-depth field analysis, crop monitoring, scanning of fields, and so on. So the image analysis, which are based on drone and which can identify many things in the field, is of great help. Computer vision technology, IoT, and drone data can be combined to ensure rapid actions by farmers. Mobile-based recommender system and expert system can drastically increase the adoption rate of agriculture technologies like high-yielding varieties or disease-resistant varieties, innovative farm implements, and thereby helping increase in farmers' income. So basically, a recommender system is a system which can choose one or two recommendations out of hundreds of recommendations available. And in daily life, you can see in e-commerce platforms, whenever you choose a particular item or buy a particular item, you see a lot of recommendations for the similar items. That is recommender system. But that same can be applied in case of agriculture as well. The use of robots in the domain of agriculture and dairy farms has advantage in terms of time management, enhancement of control, and reliability. Now let's see some of the live examples which are available across the world in the field of agriculture. So, Blue River Technology, a company, developed a robot See and Spray that uses computer vision technology to monitor and precisely spray herbicides on cotton and soybean farms. Harvest Crew Robotics developed a robot to help strawberry farmers in picking and packing of their produce. Trace Genomic provides soil analysis services to farmers, which include information related to bacteria and fungi through pathogen screening and microbial evaluation by performing the soil DNA analysis. So these three you can say totally different in different areas and how they helped the farmers and end users through the use of AI. Similarly, we uses satellite imagery data in the farms based on many points, daily data on agronomic and climatic data, predict weathers, crop sustainability, and the occurrence of disease and pests. Reason has developed images recognition algorithms that can detect and classify plant pests and disease more accurately than a trained human. Eggvoice has developed a natural language processing toolkit for interpreting sudden death syndrome of soya fungal disease and prompts for the location and severity of the observation. Pete has developed a deep learning based application called Plantix, also available in India widely for identifying the potential defect and nutrient deficiency in crops. Similarly, CRISAT is using satellite imagery and drones to delineate land boundaries accurately under imagery forms for small farmholders. Farmers can precisely identify area and borders of their land, leading to effective management of land. Bitponics is a cloud-based solution offering automated advisory services for garden care. Growtronics is a modular system that can monitor almost every aspect of indoor gardens. Similarly, CropX is a complete system including field ground sensors measuring soil moisture and temperature, offer a mapping and optimal irrigation plannings as a service to the growers through a mobile application. So a lot of things has happened, and I am just describing all this to give you an idea that what all is happening. And as you all are from very diverse fields of agriculture, you can also think of a similar situation or similar application in your areas. And in this training program, basically, we will cover the techniques which you can use to at least formulate few problems in your area of research, which you can use or you can have a solution through AI. ICR institutions are not behind, and they have also developed many applications. AgriDaksh, a tool developed by ISRI for maize and tobacco and rapeseed mustard and solanaceous crop, is basically an expert system which helps farmers to take decisions. eCrop solution based on IoT has been developed by CTCRI using simulation and machine learning models. Advisory on water management, yield gap, and other management strategies are sent to farmers via SMS on a daily basis. At ICR IIWM, ANN model for prediction of water table depth in a hard rock basin of Niagara block of Odisha has been developed. Many ICR institutions like ISRI, NDRI, NAP, NBAJR, FGR, IIWM, NARM, IVRI, and others have contributed immensely to AI by way of doing research in various machine learning techniques such as ANN, fuzzy systems, genetic algorithms, precision farming, classification and regression tree, random forests, SVMs, rough sets, wavelets, vision network, etc. All these techniques of AI really help in solving so many problems which we encounter in our day-to-day life. ICR, NAM, and ISRI has started various training programs. One which you are attending on AI and IoT, and these modules form the core for advanced AI techniques like deep learning, IoT, and image analysis. And we are trying to help each one of you to learn AI so that this transformation happens and more scientists and students become AI literate so that they can solve the problems. So let's see what are the essentials of AI. So there are three elements to it: data, models, and processing power. Data must be secure, trusted, and highly available. We need to have models which we can develop, which can decipher web scale data, and we must have processing power, which should be lightning fast. So we have GPU servers for that, and we require many more GPU servers if we want to really cater to the need of the nation. So one such tool, or we can say programming language, which is basics of nowadays for AI. You can have AI in any language, maybe in C++, Java, Python, R, but really Python has taken a leap forward, and we will also be teaching you Python programming language in this training program. So Python is one of the most popular programming language nowadays. It is a high level interpreted interactive and object oriented programming language. It is very easy to learn. It was created by Rosam in 1991 at the National Research Institute for Mathematics and Computer Science in the Netherlands. And Python programming language is mainly used for dataset handling and visualization, performing complex mathematical computation, analysis of variety of data such as numerical, text, image, videos, implementation of AI-based algorithms, server-side scripting for developing web application, and so on. So we will be discussing some of these libraries: NumPy, Panda, Matplotlib, etc. And these libraries are very important when you will develop AI-based algorithms or AI-based solutions. So some of the packages will be dealt in detail in this training program. NumPy stands for numerical Python, which is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. It is widely used as a replacement of MATLAB, a popular platform for technical computing. It is open source, which is an added advantage of NumPy. Pandas are Python library for multi-dimensional data manipulation and analysis tool, importing for loading, manipulating, and pre-processing and analyzing data for machine learning and AI algorithms. Matplotlib, most popular Python package for data visualization. It is a class platform, a platform library for making 2D plots from data in arrays. Matplotlib, along with the NumPy, can be considered as the open source equivalent of MATLAB. These libraries are a prerequisite to apply any machine learning or AI algorithm on user's own dataset. Alternatively, you can also use R language. This is a programming language for statistical computing and graphics supported by R core team. And it is also having many good libraries. And this institution has developed multiple, more than 50 R packages which are available free of cost as a general GNU package for public use. And you can also explore R for certain AI techniques. Now let's come, although this topic AI and deep learning model will be dealt in very great detail. There will be few classes, but just to summarize or just to give an idea, we need to focus more because this training program is all about machine learning and deep learning. So, machine learning, very clearly, as I told, is a subfield of artificial intelligence. It refers to the concept, construction, and study of systems that learn from data. So, what is the definition of a machine learning? If you say a mathematical definition, a computer program is said to learn from experience E with some class of task T and a performance measure P if it performs a task in T as measured by P improves with E. What we want to say here that, as I told, that the experience E can go on increasing with time, or a machine can go on learning more and more as more and more data comes. So it learns with experience for a particular task T and with a particular performance measure P. But if the machine performs the task T better and better, it if improves with experience E, which can be measured by P, then we can say a machine is learning. So machine learning provides systems the ability to automatically learn and improve from experience without being explicitly programmed. This is the classical machine learning workflow. You have input data, then you do manual feature selection, and then you create models for classifying those features, and then you make prediction. So classical machine learning approach requires careful engineering and considerable domain expertise to design a feature extractor that transforms the raw data into a suitable internal representation from which the learning subsystem, often a classifier, could detect or classify patterns in the input data. But what are the limitations of a classical machine learning approach? One of the big challenges with traditional machining approach is manual feature extraction process. And as you are aware, how many features can be extracted manually? 10, 15, 20, 30, 50, 100. It's very difficult to go beyond that. And that's where the actual biological phenomena or actual phenomena which has a real life experience, we were not able to solve those much with simple classical machine learning approach because of the limitation of the fact that manually limited features can be learned. So only problems with a very specific boundary level conditions with very specific uh, uh, options can be solved through a machine learning approach. Simple classical machine learning. So working with high dimensional data is not suitable for classical machine learning approach, not appropriate for solving crucial AI problems such as image recognition, NLP, etc. But with the help of deep learning, which is an advanced machine learning approach in the field of computer vision, it allows computational models that are composed of multiple processing layers to learn representation of data with multiple levels of abstraction. Deep learning is basically a representation learning approach that learns the representation in each layer from the representation in the previous layer. In recent years, the deep learning have emerged significantly achievements in image, video, and audio processing and NLP, etc. So one such example we will share with disease and pest identification. The main building block of deep learning is ANN, and ANN are motivated by functioning of biological neurons, as I already told. The ANN are themselves general function approximations, where it learns a complex mapping from the input data to the output space. The deep convolution neural networks, CNN we call, have brought about breakthroughs in processing images, video, speech, and audio data. While the recurrent neural networks have shown light on sequential data such as text and speech. You can see in a convolution neural network, the class of artificial neural network that are used for analyzing, classifying visual images. So you have input image, you have a CNN network, and you have an output label image class. So they have the capability to automatically extract features from the raw data and learn the pattern recognition within the data. So when we have a manual machine learning, we can go to certain features. Number of features can be limited to uh, maximum to 100 or few hundreds, but here it goes into millions. So you can have millions feature out of a particular image data set, and which is then analyzed to give you the exact answer. So basically, CNN is supervised machine learning approach consisting of four processing layers: convolution layer, pooling layer, flattening layer, and dense layer. And not devote much time here on this describing these layers, as we have a complete class on deep learning. But just to understand the concept now, you can see that there is a label data. You can just define features and create model, which is done automatically by CNNs, and you can make predictions. So the prediction becomes very easy because the main task is done automatically by CNN. The CNN models are capable of identifying objects in the images. So one can give an image and it can classify and tell that this is a leaf or a tree. You can say this is a cow and this is a human. The simple capability of identifying objects automatically by giving an image, and it can identify what type of object is there in that image, is of immense use. And huge number of applications are based on that, including your uh, Digiyatra and uh, the auto driving cars, and many more, which we can see in robotics, maybe weed analysis, maybe pest and disease identification, maybe phenotypic characters. All that are based basically on object detection. So you can classify object, which is you can see a cat, and you can also identify multiple objects in a single picture. You can say cat, dog, duck, etc. So basically, if you want to see that how machine learning works, so you need to have a lot of data, internal data and external data. You need to convert it into a data pipeline, which will be deposited into a data lake, on which algorithms and models will work, and then the recommendations is generated, and you can finally measure the performance of these recommendations. So do it yourself machine learning can be very difficult and expensive, but the strategy is making machine learning easy and very easy to put to work, and that is now democratized, and many such platforms are available, which you can learn in this training program, like Keras or TensorFlow and all that, and through which you can at least you need not understand the underlying architecture of each one of these to use it. Just like you need to drive a car, you don't understand how it is built. So you just need to learn how to drive. And similarly, you can use these platforms just to give you your own label data, and rest everything which will be done by the algorithms, and then you can use it as an output. So one such example which ISRI has worked upon is, I told, disease and pest identification. And this you can say the neural network, deep learning network learns through it and it predicts. So it predicts healthy plant. It can this is example of maize plant, and you can say the maddis leaf blight or triticum leaf blight or insect damaged by a plant. All this can be done. So this algorithm, this particular technique we have used in developing this mobile app, which we call this AI disk, artificial disease based, artificial intelligence based disease identification system for crops. And this is again, we will have a lecture on this. This is developed in multiple projects and it is deployed on ICI data center. And this is the architecture of AI disk. We gather data from across the India with our partners, and we did so in an app called as National Image Based on Plant Protection (NIBPP). Uh, we can have your user ID also created on this particular app. I request all of you to download an AI Disk app, as well as some of the users can who are pathologists or entomologists can download NIBPP and we can create user ID for that. Then we have created NIBP metadata, and then images are labeled, and then finally we have pre-processing of these data. Then finally it is fed to the model, and then it is now available as a mobile app for the final detection of diseases. So now more than 20 crops are available. Rather, it has gone to 23 crops, more than 70 diseases, which we can identify by using this mobile app. So this is how it works. So we have 12 partners, mostly state agriculture universities and ICR institutions. We have collected number of images, more than now 4 lakh images we have collected, and there are different type of users available: extension worker, domain experts, account administrator. All this will be dealt in detail in a class where AI disk will be explained. So finally, the identification is possible, reporting is possible, and there is also an expert forum which can help you. So these are various screenshots of the AI disk app, where simply you can see how simple interface it has. You can take a photograph or you can take it from the gallery, you upload it, and you press identify button. And once you press the identify button, just on a click of a button, it will identify the disease. It will give you all the basic characteristics, symptoms, and it will also give you the control measures. Uh, if the disease is not identified, some of the diseases, you can reach out to the expert forum. This is the workflow of AI disk. These are technology used in developing AI disk. And we have also listed all the main features. And I think Dr. Chandan will give you that. Let's try to see some of the more examples of AI using image analysis. So digitizing food quality is one. This is one such example which is developed by Intello Labs proprietary solution. And this is in general stores, the food chain stores. You want to predict the quality of the tomatoes because you want to fix the price on a daily level. So as the product is fresh, you need to have more price, and if the tomatoes are rotten, then you need to decrease the price. So as of now, without AI, the e-store owner is to decide this particular thing, and for hundreds of stores, this becomes a challenge because the price varies from person to person, and company can have great losses. So by just clicking a photograph, it is uploaded, and you can identify how many is good potatoes, how many is bad, and based on that, the price can be actually find out. This is one very simple example, but very useful for the store owners. Similarly, there are other technologies like one with this device called as Fasal is a full stack platform for progressive horticulture. This is the company says that farmer makes 5 critical decisions every day. There are so many pests, disease, climate management, fertilization, irrigation, and for that, lot of data points are required. And to help him across the country, and they have installed these devices, and these devices they can gather data on multiple aspects. The data is available, you can see on various sensors available on this their device. It can also detect soil moisture sensor. It can also give you the wind speed and wind direction. It can also have the other things like air temperature sensor, air pressure sensor, relative air humidity. lux sensor, solar intensity sensor, wetness sensor, etc., as well as rainfall gauge, etc. So this single device, if uh, is there in the field, it gives a lot of data points, and based on data points, they have algorithms to solve, and they have app which can monitor various parameters, and based on that, various decisions can be given to the farmer. I will conclude with this slide that this is a technology adoption slide which says that years taken until adoption by 25% of the US population. And you can see in this that electricity is almost taken 46 years to reach to 25% of the US population. Telephone took 35 years, radio took 31 years, television 26, your PC took 16 years, cell phone 13, World Wide Web, the internet took 7 years, iPhone 2.7 years, Facebook 2 years, Twitter takes 9 months, and the AI based Pokemon Go, which is an augmented reality game, took only 19 days. So nowadays, if a good technology comes, a technology which can solve a real life problem, which is AI based, can take only few days to reach to the masses. And you know how a viral videos or viral photographs goes. And similarly, a technology which can penetrate to the farmers, you can have a lightning speed way to reach to the farmers, and they can adopt and can change the scenario in a very nice way. So I conclude that let's be clear that AI would be useful if applied on relevant data sets, historic, current, or amalgamation of the two depending upon the purpose of application. Relevant quality data, understanding of the context of the problem, selection of AI techniques are going to be the key factors for successful applications. As per the discussion paper on National Strategy for AI, Niti Aayog, focus areas for artificial intelligence in agriculture should result into enhanced farmer income, increased farm productivity, and reduction of wastage. With this, I thank each one of you for patience learning, and we will be interacting more on this in the contact class. Thank you.